Hello everyone. So we were discussing symmetry elements and this is the third video, and here we are going to discuss axis of symmetry. It is one of the most important symmetry element. Now axis of symmetry or rotational symmetry. Now what do you mean by axis of symmetry? Now imagine that this is a crystal. Okay, so this is an eraser having 6 sides. So this is the front side, same similar face, exact faces are there in the front and back. These are the side faces. This face is exactly same as this face, so this side and this side, they are the same faces, and the face on the top and the bottom, they are the same faces. So front and back, they have same faces, sides, they have same faces, and top and bottom, they have same faces. All right, so this is an eraser. Imagine that this is a crystal. Now what is an axis of symmetry? So imagine that a axis passes through the center of this crystal. So from the top along the C axis, and it passes through the center of the crystal and it comes out. Now if you rotate along this axis, when you rotate this, the eraser will also rotate. Okay, when you are rotating this axis, eraser will also rotate along with it. Okay, so when you are rotating it, the same face, so suppose this is the face, it has, this is the front face, right? Exact same face is present on the back side, right? So when you're rotating it along that axis, the same face should appear. So when you're rotating it 360 degrees, so when you're rotating it 360 degrees, the face, the same face should appear at least twice. So एक पूरा रोटेट कर दो, 360 डिग्रीज रोटेशन जब दोगे, यही सेम फेस दो बार रिपीट होना चाहिए. सो सेम फेस शुड रिपीट at least twice. Then it is said to have axis of symmetry या rotational symmetry है, तब हम लोग बोलते हैं at least twice. So it can be more than twice, right? So suppose cube है, उसमें axis of symmetry is present. So there are many axes of symmetry. So 4-fold rotation है, 3-fold rotation है, 2-fold rotation. So we'll see that example later, right? So there you have 4-fold rotation. So every 90 degrees you have the same face. In the case of dice, imagine the dice में सारे faces का same dimension होता है. So when you rotate it 90 degrees, every 90 degrees you will have the same face. Okay, so minimum दो बार आना चाहिए. So when you rotate it complete 360 degrees, same face should repeat at least twice. Then it is said to have axis of symmetry or rotational symmetry. All right. There are crystals which do not have axis of symmetry, यानी पूरा 360 डिग्रीज घुमाना पड़ेगा आपको सेम फेस आने के लिए. तो यहां पर क्या है, 180 डिग्रीज घुमाओगे तो सेम फेस वापस आ जाएगा. पर कुछ क्रिस्टल्स में पूरा 360 डिग्री जब तुम घुमाओगे तो सेम फेस रिटर्न करने के लिए पूरा 360 डिग्रीज घुमाना पड़ेगा उसको. सो इट हैज वन फोल्ड रोटेशन एक्सिस. सो इट मींस इट डज नॉट हैव रोटेशनल सिमेट्री. यानी वन फोल्ड रोटेशन एक्सिस है, इसका मतलब तुम्हारे पास रोटेशनल सिमेट्री नहीं है. एटलीस्ट दो बार आना चाहिए, यानी 180 डिग्रीज घुमाओगे तो सेम फेस आना चाहिए. 360/2 मिनिमम ट्वाइस, यानी 360 डिग्रीज बाई 2 दैट इज 180 डिग्रीज. सो एटलीस्ट 180 डिग्रीज जब तुम घुमाओगे तो सेम फेस तुमको मिलना चाहिए. ओके, सो अगर किसी क्रिस्टल में पूरा 360 डिग्रीज घुमाओगे तभी वो सेम फेस आ रहा है, इसका मतलब it has one fold rotation axis, it does not have axis of symmetry. All right, so let us see the theoretical part. Okay, so axis of symmetry, what is it? So axis of symmetry, it is defined as an imaginary line in a crystal passing through the center in such a way that when a crystal is given a complete rotation, यानी 360 degrees rotation की बात कर रहे हैं. So when you give complete rotation along this line, a certain crystal face taken as a reference face. So I am taking this as a reference face. तो वापस इसी फेस को लाने के लिए मुझे कितना घुमाना पड़ेगा, ये वाला फेस लाने के लिए. सो आई हैव टू रोटेट 90 डिग्रीज, अगेन 90 डिग्रीज. तो 180 डिग्रीज अगर मैं घुमाऊंगा तो सेम फेस वापस आ जाएगा. यानी फुल रोटेशन, इफ आई गिव 360 डिग्रीज रोटेशन, इट शुड रिपीट एटलीस्ट ट्वाइस. दो बार सेम फेस आना चाहिए. सो if it is given complete rotation along that certain axis, the same face, जिसको reference face की तरह हम लोग देख रहे हैं, it comes to occupy the same position at least twice, minimum 2 बार occupy करना चाहिए. That means 180 degrees जब तुम घुमाओगे तो same face आएगा. In fact, it may occupy the same position more than twice also. So based on that, so this axis of rotation can be through C axis, हो सकता है ये C axis के थ्रू हो, okay, or it can be through A axis or it can be through B axis. So हो सकता है कि ये B axis के थ्रू भी हो या फिर A axis के थ्रू भी हो. So it should pass through the center of the crystal. वो C axis के थ्रू भी जा सकता है, B axis के थ्रू भी जा सकता है या फिर A axis के थ्रू भी जा सकता है. Okay. Now the angle of rotation needed to bring a reference face to the same position, that is to repeat itself. Same face को वापस लाने के लिए कितना डिग्री रोटेट करना पड़ेगा? So based on that we have different types here. So one fold rotation axis, or you can say no symmetry. इसमें सिमेट्री है नहीं क्योंकि 360 डिग्री पूरा घुमाना पड़ेगा उस फेस को वापस लाने के लिए. कंडीशन क्या था? when you give a full rotation, when you rotate it 360 degrees, at least twice it should repeat. यहां पर तो सिर्फ सेम फेस वापस लाने के लिए उसी पोजीशन पे पूरा 360 डिग्रीज घुमाना पड़ रहा है. So it does not have same face repeat नहीं हो रहा है. So an object that requires rotation of full 360 degrees in order to restore to its original appearance has no rotational symmetry. It does not have rotational symmetry since it repeats itself one time in every 360 degrees. So 360 degrees पूरा घुमाओगे तभी तुम्हारा same face वापस आएगा. That means it does not have any rotational symmetry. So one fold rotation axis, it is said to have one fold rotational symmetry or no rotational symmetry. Simply no rotational symmetry क्योंकि minimum 2 बार आना चाहिए. यहाँ तो एक ही बार आ रहा है. 360 degrees घुमाओगे तो only once it is repeating. Okay, at least it should repeat twice. So it has no rotational symmetry. Now second one is two-fold rotation axis. यानी ये जो axis है, if you rotate it completely 360 degrees, तो at least 2 बार ये face तुम्हारा same position पे आएगा. At least twice it will occupy the same position. So an object appears identical after rotation of 180 degrees. यानी 2 बार आएगा ना, यानी 360 degrees by 2, that is 180 degrees. So when you rotate it 180 degrees, अब मैं इसको 90 degrees रोटेट कर रहा हूँ. 90 degrees में ये वाला फेस आ जाएगा, फिर 180 degrees में सेम फेस है ना. ये फ्रंट एंड बैक सेम फेसेस हैं. So if I rotate it 90 degrees, it will have this side face. फिर और एक 90 degrees घुमाऊंगा तो सेम फेस आ जाएगा वापस. राइट. सो 180 degrees घुमाओगे तो सेम फेस अपीयर होगा. देन इट इज टू फोल्ड रोटेशन एक्सिस. सो इट इज रिप्रेजेंटेड बाय लेंस इन द मिडिल. तो इसको जब हम लोग स्टीरियोग्राफिक प्रोजेक्शन दिखाते हैं, सो इन द मिडिल इट विल हैव ए लेंस. इट इज रिप्रेजेंटेड इन द फॉर्म ऑफ लेंस इन द मिडिल, इस तरह से. ओके. सो टू फोल्ड रोटेशन एक्सिस कैसे? सो ये तुम्हारा सपोज रेफरेंस फेस है. सो इसको अगर तुम 90 डिग्रीज रोटेट करोगे, सो ये फेस, सो हम लोग क्लॉकवाइज रोटेट कर रहे हैं. इमेजिन वी आर रोटेटिंग क्लॉकवाइज. सो 90 डिग्रीज रोटेट करोगे तो ये वाला फेस यहां पर आ जाएगा. फिर 90 डिग्रीज रोटेट करोगे तो ये वाला फेस यहां पर आ जाएगा. सो ये वाला फेस को यहां पर लाने के लिए 180 डिग्रीज रोटेट करना पड़ेगा तुमको. यू रोटेट 90 डिग्रीज, दिस फेस विल अपीयर हियर. अगेन 90 डिग्रीज, ये वाला फेस यहां पर आ जाएगा. Got it? Now, three-fold rotation axis. So, for every 120 degrees, same face will appear. Three-fold rotation axis means 360 degrees divided by 3, यानी एक पूरा 360 degrees rotate करोगे तो 3 बार same face वापस आएगा. That means for every 120 degrees, हर 120 degrees जब घुमाओगे तो same face repeat होगा. So objects that repeat themselves upon rotation of 120 degrees are said to have three-fold rotation axis. All right. So इसको सेंटर में हम लोग एक सॉलिड ट्रायंगल की तरह रिप्रेजेंट करते हैं. ये इक्विलेटरल ट्राइंगल है, ऑल द फेसेस आर सेम, सो एवरी 120 degrees you will have same face. Then we have four-fold rotation axis. So 360 by 4, that means 90 degrees. So every 90 degrees when you rotate, you will have the same face. तो इसको so all these faces are same. ये वाला face, ये वाला face, ये सब same faces हैं, equal dimension. So every 90 degrees you will have the same face. Same face repeat होगा. Okay. So if an object repeats itself after 90 degrees rotation, it will repeat 4 times in a 360 degrees rotation. Okay. So four-fold axis of rotation. So it has a four-fold axis of rotational symmetry. Then six-fold rotational axis. So if a rotation of 60 degrees about an axis causes the same face to repeat itself. तो यहाँ पे देखो, six-fold rotation axis means 360 by 60, that is 60 degrees. So every 60 degrees, so when you rotate 60 degrees, same face will appear. हर 60 degrees पे same face appear होगा तुमको. Then it is said to have six-fold rotation axis. So इसको represent करते हैं center में with a solid hexagon. Okay, in stereographic projection center में हम लोग solid hexagon से represent करते हैं six-fold rotation axis. Now, so although it might appear, so objects themselves may appear to have five-fold, seven-fold, eight-fold, or even higher fold rotation axis. They appear to have five-fold, seven-fold or higher fold rotation axis, but actual में ऐसा नहीं होता. Crystals, natural crystals जो हैं, they don't have five-fold, seven-fold or eight-fold rotation axis. They are not possible in crystals. Okay. So the reason is that the external shape of the crystal is based on the geometric arrangement of atoms, है ना? So atoms are arranged in an orderly manner in a mineral that gives the external shape. So external manifestation or external shape or form of the crystal is based on the internal arrangement of atoms, है ना? So here in the diagram you can say, yeah, तो five fold rotation या pentagons की बात कर रहे हैं, five fold rotation symmetry, और here we have eight fold. So if you try five-fold rotation or eight-fold rotation, if we combine objects with five-fold or eight-fold apparent symmetry, we cannot combine them in such a way that the gaps are completely filled. So यहाँ पर देख सकते हो तुम eight-fold octagons को हमने साथ में लाओगे तो center में gap बच जाएगा. So there will be empty spaces. So crystals में this is not possible. So crystals में empty spaces possible नहीं है. So that is the reason why we don't have five-fold, seven-fold, eight-fold or higher fold symmetry, because if you join them, so two dimension में if you try to use them to join, बीच में ना empty spaces बच जाएंगे. So which is not possible in crystals. So that is why we don't have five-fold, eight-fold और seven-fold rotation symmetry. So यही एक तुम्हारा यूपीएससी में क्वेश्चन पूछा था. सो दिस इज अ पीवाईक्यू, मेंस में ये क्वेश्चन आया था. सो व्हाई डोंट we find five-fold, seven-fold rotation in crystal systems? So this was a part of compulsory question. So question number 1 paper 2 में, so I guess it was part A or B, या A था या B था, मुझे याद नहीं है exactly, but it was asked recently, 2-3 साल पहले पूछा था. ठीक है. So this was the question, why don't you find? So we have seen the answer, right? हमने देखा था कि when you try to combine these shapes, तुम्हारा जो crystal lattice में unit cell, it repeats itself, right, in all directions, and there should not be any empty spaces when you join these unit cells. There should not be any empty spaces. All right. So we don't find 5-fold, 7-fold, 8-fold or higher fold rotation systems because it is not possible to fill the to make a crystal with these symmetries without any gap. So the absence of crystals with 5-fold or 7-fold symmetry is explained by the fundamental principles of crystallography and structure of periodic lattices, right? So your unit cell repeats in all direction in the lattice. So there will be gaps left if we have 7-fold or 8-fold or 5-fold symmetry. So you can use these slides to make your notes directly. तुम इससे notes बना सकते हो, okay? So this will fulfill that purpose. So your answer is right here. Now first is the first reason why we don't have, because if you join them together you can see there are empty spaces. So crystal में वो possible नहीं है, okay? So crystals are periodic structures, that means repetition हो रहा है, unit cells are repeated in the crystal lattice. So crystals are periodic structures that repeat in space. Okay, this is how you start. So for a pattern to fill the space without gaps, the arrangement of atoms must repeat in regular and continuous way. But यहाँ पे देखो तुम, gaps बच जाता है. If you have 5-fold or 8-fold, you can see gaps. So crystal में gaps नहीं आने चाहिए. So this repetition should be in a regular manner without any gaps. So when tiling, so जब तुम 2 dimensional में, when you are tiling a plane, घर के अंदर तुम्हारा जो फर्श है, टाइल्स तुम लगाते हो ना, so when you are tiling a plane, so 2D में with polygons, only certain symmetries allow for this periodic tiling. या तो 2-fold, या तो 3-fold, 4-fold and 6-fold symmetries. So you can have only these symmetries for perfect tiling of a plane. So 2-fold में तुमको इस तरह के टाइल्स तुम लगाते हो, या तो तुमने देखा होगा, जितने भी तुमने देखे होंगे टाइल्स, कहीं पर भी देखे होंगे टाइल्स, तो इस तरह से टाइल्स होंगे 2-fold सिमेट्री में. और यू हैव दिस काइंड ऑफ टाइल्स, इक्विलेटरल ट्रायंगल, ऐसे tiling can be like this also, right? Or you have square tiles, 4-fold rotation axis, square tiles, or you have hexagons. इस तरह से ये 6-fold रोटेशन है, 4-fold रोटेशन, 3-fold रोटेशन एंड 2-fold रोटेशन. Higher 5-fold, 8-fold rotation, 7-fold rotation, they are not possible because they leave gap. अगर यहाँ पे तुम ब्लैक वाला कोई, तुमने ऐसे भी देखा होगा, ब्लैक वाला टाइल अगर कोई यहाँ पर लगा दो तो वो एक डिजाइन बन जाता है, बट ये तो तुम्हारा परफेक्ट अरेंजमेंट ऑफ टाइल्स नहीं, यहां तो तुम दूसरा कुछ लगा रहे हो. हाँ, सो तुम्हारा क्रिस्टल लैटिस रिपीट नहीं हो रहा, हियर इज सम अदर, यहां पर तो दूसरे एटम्स है, राइट? सो गैप विल बी लेफ्ट. सो ऐसा गैप बच जाएगा अगर तुम 8-fold या फिर 5-fold सिमेट्री होगा तो. सो इन क्रिस्टल्स, natural crystals, it is not possible. Only these symmetries are allowed. So these symmetries correspond to 4-fold, 3-fold, 6-fold or 2-fold. So 5-fold symmetry such as a pentagon and 7-fold symmetry cannot tile a plane periodically without leaving gaps. Gaps बच जाएंगे. So gaps है, इसका मतलब तुम्हारा जो crystal है, it is not perfect. Okay. So there should not be any gaps left when your unit cell is repeating in the lattice. So that is main reason. Okay. Second, mathematical constraints भी हैं. So mathematical constraints, so rotational symmetry and periodicity. So in crystallography, the rotational symmetry of a crystal lattice must allow for periodicity. So ये जो periodicity है, it is only possible when you have 1-fold rotation. Obviously 1-fold rotation को हम लोग periodic, because 1-fold rotation में periodicity कहाँ है, repeat नहीं हो रहा है. So 1-fold rotation is considered as no rotation symmetry. So 2-fold rotation, 3-fold rotation, 4-fold rotation and 6-fold rotation, है ना? 360 by 2, 360 by 3, 360 by 4 and 360 by 6. Perfect division होता है. Okay. So the rotation angles that preserve the periodicity are limited to 2, 3, 4 and 6. 1 को तो हम लोग कंसिडर ही नहीं करते. So even though you तुम लिखो ना लिखो, it doesn't matter. So at least twice the phase should repeat, right? 2-fold symmetry, 3-fold, 2-fold rotation, 3-fold rotation, 4-fold rotation, 6-fold rotation. Only these they will give you perfect periodicity. So for instance, a square lattice 4-fold symmetry है तो 90 degrees. So 360 by 4, 90 degrees. Hexagon में so every 60 degrees it will repeat. But अगर तुम्हारा 5-fold होगा, so 360 by 5 will give you 72 degrees. Again, perfect periodicity नहीं मिलेगा इसमें. Okay, without gaps बच जाएगा यहाँ पर. So for 7-fold symmetry, you see 360 by 7, it will give you 51.43 degrees. Again, there will be gaps left. So perfect periodicity 5-fold and 7-fold में नहीं मिलेगा तुमको, 8-fold में भी नहीं मिलेगा. So perfect periodicity तुमको सिर्फ 2-fold rotation, 3-fold rotation, 4-fold and 6-fold rotation में ही मिलता है. So these two are your points. ठीक है, तो ये तुमको आंसर में लिखना है. Why don't we find 5-fold and 7-fold rotation in crystal systems में? So these 2 points you can make notes from here and prepare your answer from here. So that was regarding the axis of rotation. So this is one of the important symmetry element. All right. So in the next video, we will see roto inversion and other symmetry elements. So that will be all. Thank you very much.